Okay, guys, we're back at it. Variable expressions, and I have a feeling I did this a little backwards. I started out working with the factors, and then with terms, but it's okay. Either way, it's all learning, and it's all in the introductory part of operating on variable expressions. So here we go. Here we have um properties of numbers, and we see earlier, we just in the previous videos, we talk about the distributive property. We talk about the associative property of multiplication, and I did mention that if you have like three terms here, the first video was showing three factors where it says AB, the quantity AB plus times C is the same as the quantity it's the same as A times the quantity BC. So as you see, the same concept applies for addition. So if you have three terms and you quantify the first two plus the last, it's the same as saying the first plus quantifying the last two. As you can see, I'm just trying to put in words as you see it visually, right? So A plus B in parentheses plus C is the same as A plus B plus C in parentheses. So the same for commutative is saying that addition could be in the reverse. So A plus B is the same as B plus A. 2 plus 3 is the same as 3 plus 2, because 2 plus 3 is 5 and 3 plus 2 is 5. So you could always substitute some constants for these variables and see that the theory works. Also, in keeping with the addition property, we learn in the multiplication property that a factor times 1 will give you back that factor. But for addition, it's called the addition of 0. The other one was called, I think, the property of 1 or something like that. Where here, if you start out with a term and you add 0 to that term, you'll get back the same term. And of course, they show that it's commutative. So whether it's 0 plus A or A plus 0, you'll still get back that A. And then the inverse, right? So this is probably called we just spoke about the multiplicative inverse, where we said that A times the inverse of itself, which is 1 over A, would give you 1. Now this, they didn't use the fancy word, but this might be the additive inverse. I mean, they should be consistent. If they're going to use a fancy word like multiplicative inverse, then why not use the additive inverse? So additive inverse would be the opposite. So A plus opposite itself, it's going to yield 0. And also, and they're showing that that's commutative also. All right, so let's get into some simplifying some expressions. So basically, I showed you earlier how you multiply expressions. I'm going to show you how you add expressions in terms of trying to simplify them. Now, you can only simplify it, or I should say, add it when you have like terms. Right? Like terms. So the terms must be like terms, which means they must have so I'll put another example up here. Negative 3x minus 8x squared. Right. So what that means is that they must have the same variable factor and same exponent simultaneously. All right. So for example, if I have 4x plus 7x minus, that's squared, sorry. Minus 3x squared minus 8x squared minus 2x squared, I can only combine, which means add or subtract the like terms. All right. So here, when they say add or subtract the like terms, to keep things simple, you only add or subtract the coefficients of each term. Right? And what a coefficient is, it's the constant factor of a variable term. Right? It's the constant factor of a variable term. So 4 is the constant factor of the variable term 4x. 7 is the constant factor of the variable term 7x. So 4 and 7 are coefficients of this expression. So whenever you're simplifying expressions, you can keep it nice and simple and just add or subtract the coefficients, and you keep the variable factor as is. That's why it must be the same. So this would be 11x. Okay? Same up here. Up here I have -3 as a coefficient, -8 and -2. So this would be a add like signs. When it's terms, add like signs, keep the signs. So this would be -13x squared. Now let's say our expression had a combination of x terms and x squared terms. The only thing, I cannot combine 11x and -13x squared because, I'm sorry, that's +11x. Right? Remember we did the solution for that. So I'm combining the like terms, We cannot combine these two terms because while they might have x as a factor, the powers are not the same. So it must be the same power. So this is just good old 11x minus 13x squared. So for example, if you were asked to simplify the expression x plus 2, what would you get? So I usually ask this question, and a lot of times, but I ask before I go into the whole gamut. It's just my own little private fun I have with students. And I would see different answers like x is equal to -2, or the answer is 3, or, I see different things because a lot of times people treat, first of all, they treat -2 because they're like, oh, you said it equal to 0. They treat it like if they're solving for x. So they treat this expression as if it's an equation. So the fact that you put x equals something, it's not correct because it's not an equation. This is an expression. If it doesn't have an equal sign, it's not an equation. You don't have to solve anything. So you have to look to see if you can combine like terms. And this is an x term and a constant. There are not like terms. So there's nothing I can do. This is in its simplest form. A lot of times also people say x is 1. So they'll say 1 plus 2 is 3. So that's a misconception that people use. I never believe that students don't know math. I always just believe that students misinterpret what they're being asked, right? So that's why I always ask my students, always one of the first things you ask yourself, am I working with expressions or equations? If there are no equal signs, you're working with expressions. You're working with equations if they're equal signs. And then I get into how you operate on the different terms and factors, because you also have, another thing is that another answer is people would say that this is 2x, right? What they've done is that they've converted this group of terms into factors, right? No, we can't be adding something and then turn them into multiples. All right, so this is another answer that I would get. So another thing you have to ask yourself, not only are you working with expressions or equations, but am I working with terms or factors? Terms require addition or subtraction. Factors require multiplication. You cannot add two numbers and then decide that they're a product. For example, if I had 3 plus 2, if this was legal, then I would say that this is 6. What did I just do with 3 and 2? I treat them like factors. I said 3 times 2 instead of 3 plus 2. And the answer really is 5, right? So these are like the simple mistakes students do when they're misinterpreting what's being asked of them. So I guess that's that. Let's do one more problem for the road. Let's do a problem with fractions and just know that the concept is same. So here we go. We have a -2/3 x squared minus 3/4 x squared. So yes, I can combine these two because they have the same variable, factor, and exponent simultaneously. They're both x squared terms. So all I have to do is to work on their coefficients, right? So I have to I'm adding because they are like signs. And what do we know about fractions? We must find an LCM. And hopefully from a past life, you will know why the LCM is 12 here. So now I have to create equivalent fractions where my denominator is 12, right? And my equivalent fraction of 2/3 to 12, I'll do that by dividing the old denominator into my new denominator, which is the LCM. And whatever factor I change my 3 by to get it 12 is the same factor I will use to multiply my numerator. So I needed a factor of 4 to get 12. So I'm going to need a factor of 4 to change my numerator. So I promise you that -8/12, if I reduce it, is the same as -2/3. So the fractions are still the same. The goal of the LCM is to make them the same quantity in order to add, because if you're adding and subtracting different quantities, it's like taking apples from oranges, right? So that's the whole goal of an LCM. So my equivalent fraction for 3/4, where the denominator is 12, right? I have to ask myself the same thing. I can either divide the 2 and I'll get 3, or I can say what factor was 4 changed by to get 12, and that's a 3. I'll multiply that by the numerator also. So that's a 9. So now I can combine my like terms. So this is actually negative 17 over 12 x squared. Right? Remember, I keep my variable factor and exponent as the same. Now, the question is this okay, or do I have to reduce? Now, first of all, 17 or 12 don't have anything in common, right? So there's nothing there to reduce. But a lot of times when students use the word reduce, they means convert into a mixed number, not the same thing. Not the same thing. Converting into a mixed number is not reducing a fraction. Reducing the fraction is finding a common factor that you can cancel out and make your fraction smaller, right? So, for example, if this was 18 over 12, then yeah, they had a common factor of 6. But this is 17. Now, if you want to convert it into a mixed, you could be my guess. This would actually be negative 1 and 5 over 12x squared, right? Either answer is okay by me. All right, let's go on to the next.